So that's going to be the y bar that we use in the rest of the question, okay? All right, fine. So if you have a look at part 4 on the screen, it basically says, can you use your answer to part 3 to estimate the value of y when x is equal to 7, okay? So quite simply, all we're going to have to do here is simply say, well, okay, when x is equal to 7, we can estimate y, so I'll put y bar because it's an estimator now. Should be equal to, plug it into that formula there, all right? So 34.38 minus 7.52 times by 7. I mean, it's going to be negative 18.26. Nice, okay? So nice and straightforward. Okay, great. Part 5. So part 5 asks the question, is this answer reliable? The answer we just got on the board, is that reliable? Can you comment on that reliability? And obviously give a reason for your answer as well. So what would you say here? Maybe if I scroll up to the previous question.
Yeah, can we go to data set?
Yeah, of course. Yeah. There you go. So there's the data set again. What do you think? Is it reliable?
No.
Why not?
Oh, minus 60. Okay. I think it's reliable.
That should be negative.
Because while the x variables are decreasing,
yep.
Increasing, sorry, the y variables are decreasing.
Good, okay.
So it makes sense that if we put 7
yeah.
x, it will give us a less variable.
Okay, so you're basically saying, well, okay, it kind of makes sense because you're saying, well, okay, if I increase the x, the y should decrease. So by the time I get to 7, we should be like negative 18-ish. Is that what you say?
Yeah.
Okay, any other ideas?
Well,
So,
I would say no.
right.
Not reliable because this calculated values interpret data.
Okay.
So it's out of, because we calculate the equation, the regression line equation, is based on this data. However, the result is out of this set of data, so
yep.
that it's not reliable.
Good, okay. Jean-Sebastian, what do you think?
Well, yeah, it's an extrapolation of the data set, and
good.
we're out of the 0.6 and 4.2x for each.
Okay, does that make sense?
Yeah. Exactly.
So the point of sort of saying, is it reliable or not, or isn't it, all you literally have to say is the value that we're trying to estimate within the range of the given data? Because the whole point is that this data, if I just quickly sketch it on a graph, let's try something like this. This is x, this is y. So yeah, we've got like 0.6 and 30. So this is 30 up here somewhere. This is 0.6, and then we got 24 and 1.2. So 24 is all the way out here. Sorry, 1.2 and 24. So it's kind of looking a little bit like this by the looks of things. Okay, so that's the data that we've got, going all the way from 0.6 up to 4.2. Okay, so you can see that the trend of data that we've got is basically a negative trend, hence the reason why I've got negative gradient, and the y-intercept's about 34, so we've kind of got a line that looks something like that. Okay, but you're absolutely right, and I think, John, you put it absolutely perfectly, which is this regression line, this model, this estimator, because ultimately that's what we're trying to do. We're trying to make predictions of our data. Okay, we're trying to say, well, okay, this is great. So basically, if you tell me what x is like 0.6 or 1.2 or 1.9 or 2, as long as you give me values that are in this data set, I can tell you what they are because I've got data values for them. But what if I wanted to make predictions for values that are not in my data set, right? This is where I'm going to have to use my regression line because my regression line literally predicts the trend of the data, okay? However, this trend has been predicted from data values, from x values at least, 0.6 through to 4.2, okay? Which means that if I'm predicting any values within this range, because this model was built out of values within this range, I know it's going to be reliable. 7 is clearly not in this range, okay? It's not even close to this range. It's nearly double the distance away from 4.20, yeah? So because it's outside this range, and I think, Jean-Sebastian, you have used the correct terminology there, it's extrapolated, okay? So just remember there are two key words here. Extrapolated means it's a value which is outside the range of given datas, okay? Interpolated means it's inside the range of given data, okay? And obviously you can make a similar kind of thing for the y's as well. So x goes from 0.6 to 4.2, the y's goes from 30 to 5. So once again, you're using a negative sort of 18.26, right, which is well outside the range of these y's as well. So again, it's more evidence to show that this is extrapolated. So this is really what you have to put down. I haven't put a full answer down. This is not enough, okay, to get all 2 marks there. I think it's 2 marks at least. Yeah, so it's not enough to put two marks down, but this would at least get 1 mark. To identify the fact that you've got an extrapolated variable, okay, which is clearly outside the range of given data. So we have to assume that the trend of data continues beyond the given range, which of course it might not do. It might do something completely different, right? So thus, it's not a reliable measure, okay? So if you put all those things down, so I'll just write down the key words there. So extrapolated, we assume the trend continues. So therefore, it's not reliable. Obviously, put this into a nice sentence for me, but for obvious reasons, I'm not going to write that on the board. Okay, so as long as you've got those kind of key words down there, so you're saying it's extrapolated value, and that the trend is assumed to continue outside the given range, therefore it's not reliable, you should get 2 marks. All right then, any questions about that?
May I ask a question?
Yes.
But, in professional life,
Yes.
if the x variable that we put in our formula
Yeah.
is out of range of data set
Yeah.
that we use to build
Yeah.
the formula,
Yeah.
then are they just ignore it?
No, no, so that's a good question actually. So in sort of real life, say if we've only got data, we can only collect data for that. You have to think about the context in which the data was collected. So clearly, for example, if we're using ages, so if x is age and y is something else, okay, then clearly if you were trying to make an estimator for like 150, that doesn't make sense, okay, because you can't have somebody that's 150 years old, all right? However, you need to look at the data which has been collected. For example, you may have a good chunk of data, you know roughly how people are expected to grow, so you know what the trend line is expected to be, and then you can make predictions off of that, all right?
Yeah.
So we don't just ignore extrapolated values, but we do need to look at the context of the question which the data was collected in, yeah? Because it may well be, for example, with something like age, it starts off linearly. You think about age, for example, age versus height. So you might have some data that suggests a linear regression, because of course this is a linear regression model, right? There are lots of different regression models out there, okay? This is just one of them, this is the one we look at in this course. But if you think about the trend of data for age against height, you do a lot of growing in the first few years of your life, and then you start to even off, and you may even start to decrease in height as you get a little bit older as well. So clearly a linear regression model would only fit for certain portions of ages. Right? So hence that kind of answers your question, which is to say, well, okay, if I wanted to estimate the height of somebody for 50 years old, but I only had data for people that were between 10 and 20 years old, then clearly that wouldn't be a good regression fit.
Okay.
All right. Good. Okay. Are there any other questions? Does that make sense? Yep. Okay, let's push ahead with question 6 then. So find the correlation coefficient for me. So the correlation coefficient, remember, it's in the formula sheet, but I'll just give it here rather than going back to it. So it's SXY divided by the square root of SXX times by SYY. Okay? So I'm just going to scroll back up. So there is our summary data at the top there. So we've got SXY. Okay? Can you just remember what that was? Or just remind me what that was?
Minus 62.73.
Thank you. We found SXX before. Just again, remind me what that was.
XXX?
Yep.
8.34.
34.
Yeah.
Okay. So we haven't got SYY. That's fine. Just write down the formula for me. So it's going to be the sum of y squared minus n times by y bar all squared. and then you can just write down the number underneath that. So we've got SYY there, John?
Yeah,
Did you find anything?
537.87.
Okay, that's great, thank you. So then we were in a position where we can just calculate Y. So it's going to be, sorry, we can calculate R. So it's going to be negative. So we know it's going to be a negative correlation coefficient, which kind of makes sense given the data. 62.73 divided by the square root of SXX, which is 8.34, multiplied by 537.87. Sorry, apologies for my poor writing there. So negative 0.94. All right. Thank you very much. So that's the calculation step. Actually, we can just jump ahead to do question 7, okay, which says fully describe what this value of R represents.
I was going to ask that.
Okay, so what does it mean?
It takes a value between 0 and 1, right?
Negative 1 and 1.
Negative 1.
Yep.
Okay, so. Yeah.
Yeah, so what does this mean? Negative 0.94. What does that tell me?
When it come closer to 1, it means there's a high correlation.
Good.
If it goes to close to -1, it means there's a high correlation, but in a negative way.
Perfect. And if it's close to 0?
There is no correlation.
Perfect. Yeah. So don't say no correlation.
So weak.
Weak correlation or 0 correlation is a better word. Do you remember what we said with 0 correlation and no correlation? Right? All we're modelling here is how well it fits a straight line. It may well be that you have data that looks something like this. That would have 0 correlation on this basis. Okay, R would be 0, right? However, there is some correlation going on there. Okay, so just because the correlation coefficient is 0 does not imply there's no correlation. Okay, it just implies that it's not following a straight line very well. Okay, so okay, question 7 then. What would you say? How would you describe it? Negative 0.94.
Well, we can be pretty confident that there's a negative relationship between X and Y. So when X increases, Y usually very likely
Yes.
to tend to go down.
Good, perfect. Yeah.
94 is not 100 and not.
No, it's not.
-1, but
No, but actually, sort of we say that anything above about 0.8, so negative 0.8 or 0.8, is usually very strong correlation, okay? So yeah, I would put 2 things here. First of all, very strong negative correlation. Sorry, I'm writing shorthand because I can't write that well. So very strong negative correlation. That's the first thing I'd put. Okay? But then you're absolutely right. I would expand on that and say, okay, as X increases, so I'll just put as X inc, then Y closely decreases. So closely dec. Sorry, my handwriting is not that great. That is dec. Okay, so you can put increases and decreases, okay? So yeah, so first things first, tell me what it means. Is it strong? Is it weak? Is it very strong? And also tell me whether it's positive, negative, or 0 correlation, okay? Second thing which I want you to expand on is what does that actually mean in the context of the question? What's the trend actually doing? So if it's positive correlation, it means as one variable increases, the other variable increases. If it's negative correlation, it means as one variable increases, the other variable decreases, okay? And I'll just expand on that to say it's closely decreasing because it's very strong correlation, okay? So those are kind of the 2 things that I'm looking for there to get the 2 marks.